In the diagram, A, B, and C are points on a Cartesian plane. F and G are points on the line AC, such that AF is equal to FG. E is the x-intercept of line AB. Okay, now let's have a look at the diagram and see what is being said here by that information. Okay, so the points B and C are given. A is still unknown, but there is, or there are these 2 points F and G that is on line AC, and they said F is the midpoint for AG, or I think they rather mentioned that AF is equal to FG, right? Making F the midpoint. And then they also mentioned on the other line, on line AB, E is the x-intercept. So this point E here is the x-intercept of line AB. Okay. Now only the coordinates of B and C are given, and then the coordinates of F, which we said is the midpoint for line AG. Okay. So remember I told you, sometimes they will give you the midpoint and you will have to work out either the coordinates of point A or point G. Okay. So this is one of those instances where the midpoint is already given and you kind of have to use the midpoint formula backwards to find out either the coordinates of A or G. Yeah. So let's have a look at the first question. Calculate the equation of line AC. That's the first question. Calculate the equation of line AC. Okay. Ashwin, do you have an input here?
Oh, no, sir.
Well, maybe you do. Try this one. The equation of line AC. So the equation of any line should always be what? The equation of any straight line.
Isn't it y equals mx plus c?
Yep. Y equals mx plus c, m being our gradient and c being our y-intercept. So how can I work out the gradient for this line?
Isn't it the change in y with the change in x?
Correct. Which 2 points can I use?
Do we use that the c, the 8 and the -4, and the f coordinate? I'm not sure.
You can use the f coordinate. Yes, that's correct. So even though they say find the equation of line AC, you can use f's coordinates because f is still a point that lies on the line AC. And the gradient between AC will be the same as the gradient between FC because they're all on a straight line. Okay, so FC, AC, doesn't matter which coordinates you use. In fact, they didn't give us AC, so we are supposed to use the coordinates of F and C. Okay, so I'll start with y2 minus y1. In fact, can you guys do this and then let me know what your answer is? Because I don't have a calculator with me. So you guys have the luxury of a calculator. You will say 3.5 minus -4 divided by 3 minus 8. Sumila has an answer, -3/2. Can anyone confirm that, please? -3/2. So the gradient
Yes,
of this line.
I got the same one.
Oh, lovely. Okay. So the gradient is -3/2. Sumila, can you now tell us how will we work out C's value, the y-intercept?
So I think what you do is that you'd substitute a point on the line. I mean, you substitute the coordinates of a point on the line, like the x and the
Yes.
y, and okay, yeah, and then you get your C.
Perfect. Okay. So let's substitute the point that doesn't have fractions. So I'm going to substitute point C just because this one doesn't have any fractions. So y will be substituted with the -4 coordinate, the y coordinate, and x will be substituted with the 8, the x coordinate. Okay. Now we just need to do a little bit of multiplication. 8 times 3/2. I think that is -12. And then if you take the -12 across, you add it on the other side. And so C would be equal to -4 plus 12, which is 8. So C is equal to 8. Right. Now I can just write out the equation for the line. So the line of AC has the equation y is equal to m, which is -3/2x plus c. No, I'm sorry, plus 8. We just worked it out as 8, so plus 8. There we go. So all the answers that you've gained, as you go along, you need to retain those answers and remember them because you might need them for future questions. Okay, let's read the next one. (3.1.2). The coordinates of G, calculate the coordinates of G if the equation of BG is 7x minus 10y equal to 8. Okay, so they are giving us the equation of BG, but it's not in the standard form. The equation, how they are giving it is, I don't know why it's written like this, but it's 7x minus 10y equal to 8. Now, this is still the equation of a line. It's just not given in the form that we want to see it in. We like looking at the equation of a straight line as y equal mx plus c. Okay, but this is still the equation nonetheless. So I'm just going to simplify it, or I guess change the form into the way that how I want to look at it as. Okay. So what I'll do is I'll take the 7x across. So I'll have the -10y here, but I'll take the 7x across. So it will become -7x plus 8, like that. I guess another thing I'll do is divide everything by the -10. So then y is equal to -7 divided by -10 should give us +7/10 with the x. And then 8 divided by -10 is negative 8 divided by 10, I think that is 4/5. Yeah, because 2 can go into 8 4 times and 2 can go into 10 5 times. So 4/5. Okay, now this is more like how we want to see the equation of a straight line, because now I can instantly read off my gradient for the line and I can instantly read off the y-intercept of the line. Okay, so it's always good to do things like this if the equation is not given not in the incorrect form, but it's almost like it's not the usual form, right? And you always want to see it in this form, y equals mx plus c, because then you can work with it easily. So I take the 7x over, then I divide by the negative 10. Okay. Now, the question is, for us to calculate the coordinates of G, let me just check if that is correct. Do they want? Yeah, they want us to find the coordinates of G. And they're giving us the equation of BG. They're giving us the equation of BG. How does this help me find the coordinates of G? Any takers? Cole, do you have a suggestion here?
So I think if we have the equation of BG and AC, then we can use a simultaneous equation to get
Yes,
G.
that's correct, because G lies both on the straight line AC and it lies on the straight line BG. So if we equate these two, if we make them equal, it's where the two lines meet, right? And they meet at G. So if we make them equal, we can find the coordinates of G, right? And it's going to be like simultaneous equations, like Cole pointed out. Okay, so the line of BG we said was negative. Nope, I lie. It was positive 7 over 10x minus 4 over 5. And then the equation of line AC is negative 3 over 2x plus 8. Okay. And we're going to solve everything by taking the x's to the one side and the numbers to the other side. Okay. So I'll have the 7 over 10x plus the 3 over 2x. And then we'll have the 4 over 5, which is now positive because I'm taking it over, plus 8. Okay. Now, because I don't have a calculator with me, I'm just going to do some finding the LCD and add the numerators. Okay, so this is 7 over 10. The 3 over 2 I can change as 15 over 10. Okay, then I'll add the 15 with the 7. So I'll get 22 over 10, which is 11 over 5. 11 over 5x. I hope I did that correctly.
Yes, sir.
Thank you. And so now the 8 over 1, I'm going to change that to 40 over 5. And so I'll add the 40 with the 4, which gives me 44 over 5. Okay. Now if I multiply everything by a 5, then I'm just left with the 11x equal to 44. And if I divide everything by 11, then x is equal to 4. Okay. So the x coordinate for point G is a 4. Melo, how would I now work out the y coordinate? I know that my x coordinate is 4. How can I now find the y coordinate for point G?
Sir, to be honest with you, I'm not sure, sir.
Think about it. We have the equation of both lines. I have the equation of line AC. That should help me find any point on the line AC. And point G is a line on AC. So if I know that the x coordinate is 4, surely I'm just going to substitute the 4 into the equation of AC. So
So
then that helps me find the y value. Yes.
okay, so you're gonna get -3/2 times 4 plus 8.
Yes. And what is that equal to?
It's equal to 2, sir.
Perfect. So please also just write down the substitution that you mentioned now. -3/2 times this x coordinate of 4 plus 8. So you guys should just keep that in mind, hey? The equation of a straight line is an equation that represents all the coordinates that fits on that line. So if I give you an x coordinate, you can easily work out the y coordinate by just subbing it in. Vice versa as well. If I give you the y coordinate, you can work out the x coordinate by, again, just subbing the y coordinate in. Okay. Right. Let's just zoom in a bit closer because the next question is now for us to show that the coordinates of A is 2 and 5. Show that the coordinates of A is 2 and 5. Now let's pretend that we don't know what the coordinates is, even though they just gave it to us. Let's pretend we don't know because we need to show it. We need to prove it. And so we kind of need to pretend that that was, we don't know it, okay? Because often what I see is sometimes you would use the answers that was given when they say, show this. Okay, you can't use the answers if you're supposed to prove something. Yeah, that would be, what do they call that? Circular reasoning. Anyways. Right, so F is the midpoint. Point F is the midpoint of this line AG. And we need to work out the coordinates of A. Okay, so this is how I would do it. I would find out how many units does point G go to the left, and then how many units do point G go up, and then we need to move F the same amount of units to the left and the same amount of units upwards. Okay. So, Dominique, can you tell me how many units does point G go to the left? How many units does it go up? And then if you do the same to F, what is A's coordinates?
So point G goes to the left. Oh wait, so are you just referring to
Like
the-
from point G to point F, if you look at the coordinates of point G to point F, how many
oh,
units does it go to the left and then up?
to the left it goes it shifts 1 unit, and then up it shifts 1.5.
That's correct. So if you move point F 1 unit to the left and 1.5 units up, where will you end up?
5, 2, and 5.
Yeah, and that's the exact coordinates that they gave us. But this is it's a bit funny to write. So I'm rather going to show you a more I don't know, should I say sophisticated way of doing this calculation? But that's just an if this wasn't like a proof question, then I would have accepted that answer. But since it's a proving question, let's rather do it the proper way. Okay, thank you for that. So we'll use the midpoint formula. So to find the x value at the midpoint, you would normally add the two x values and you divide that by 2. Okay. The thing here is we already know that the x value at the midpoint is 3, but one of the x values are unknown. The other x value I know is it's 4, right? So I can say x plus 4 divided by 2 is equal to 3. And now I can solve x. Okay. Wait. Am I doing this correctly? Am I doing this correctly? Doesn't look like we're going to get that answer. So did I make a mistake? Okay, let me just see. So I'm going to cross multiply x plus 4 times 1. And then 3 times 2 is 6. And then, yeah, then x is equal to 2. There we go. So that's the same answer that Dominique gave me, where x is equal to 2. Okay. Thank you, Simila. For some reason, I was thinking that my answer was supposed to be 4 and not 2. But that's correct. Okay. Now let's do the same thing for the y values. Okay, so I'll say y at the midpoint is equal to the first y plus the second y divided by 2. Okay, now we already know that the y at the midpoint is 3.5. So if we just add the unknown y plus the known y, which is 2, and divide that by 2, then we can solve y. Okay, so again, cross multiply. Y plus 2 times 1 is y plus 2. And then 3.5 times 2 is 7. Okay, and if you minus 2 on both sides, 7 minus 2 is 5. There you go. So there we worked out x as 2 and y as 5. And I guess this is a bit more sophisticated and worth 4 marks. Well, how much marks is it? It's probably just 2 marks. But yeah. This is worth that 2 marks because they asked us to prove that it's equal or to show that it's equal to that. And so we kind of had to do a little bit of, calculation. Right. Prove that EF is parallel to BG. Okay. In analytical geometry, how do we prove that lines are parallel? In analytical geometry, how do we prove that lines are parallel? Kristen.
So, don't the gradients have to be equal?
That's correct. The gradient of line EF has to be equal to the gradient of line BG. Okay, so let's see where are these two lines. EF is the short line inside the triangle, and BG is the longer line at the bottom of the triangle. Now, if I'm being honest, there's actually more ways of proving that this is parallel, but I'm just going to use the fact that if you prove the gradients are equal, then the lines will be parallel. I'm just going to use that. But there is more ways of proving that these lines are parallel. Okay. Now, do we know what the gradient of line BG is? I think we know what the gradient of line BG is because they gave us the equation of line BG. So if I just write out what that was, minus 4 over 5, I can now see that the gradient for line BG is this 7 over 10. Okay, so this is the gradient of line BG. Now that's great. If I can now just prove that the gradient of line EF is also 7 over 10, then I know that they are parallel. Okay. But here's the thing. how do I work out the coordinates of E? Michaela, how would you work out the coordinates of E?
So I would take the equation of line AC and make y 0 since it's the x-intercept.
That's correct. The equation of line AC and make y 0 because it's the x-intercept. Okay, but we don't have the equation of line AC, so, or AB, pardon me. So let's work out the equation of line AB first. Okay, so y is equal to mx plus c. This is for the equation of AB. So A's coordinates is the 2 and 5, and B's coordinates is the -6 and 5. That's here at the bottom. And so I'm going to use those coordinates to work out the gradient and the y-intercept. And then once I have that, I work out the x-intercept for coordinates E. Okay, sounds like a lot, but it's all easy stuff. Okay, so we first do the gradient. 5 minus -5 over 2 minus -6. What's this equal to? This is the gradient for line AB. The double negatives you can just type in as a plus. So that's 5 plus 5, which is 10, and 2 plus 6, which is 8. And 10 over 8 can be simplified as 5 over 4. Okay, so the gradient for line AB is 5 over 4. 5 over 4. So to calculate C, I'm now going to substitute a point, just like how I did in the other time, like how we did in the other case. Okay, so I'm going to substitute point A, just because there's no negatives there. All the coordinates is positive. So I'll substitute point A. The y is 5, and the x is 2. Okay. So can you work out C's value, the y-intercept for AB, after the substitution? You will first have to multiply the 5 over 4 with the 2, which gives you 5 over 2. And then you'll have to minus it. 5 minus 5 over 2, which is actually also 5 over 2. So C's value is 5 over 2. Right, so we actually now have the equation of line AB. Okay, let me just write it out. The equation for line AB is y equal to 5 over 4x plus 5 over 2. Okay, I now need to make y 0 because I'm trying to work out the x-intercept. So I need to make y 0. Okay, then I'm going to take the x's to the left and divide by the -5 over 4. Okay, so I take the x to the one side, which gives me -5 over 4, and then I'm going to divide by that eventually. And what's the answer when I divide 5 over 2 by -5 over 4? What is x equal to?
-2, sir.
Thank you. So The coordinates for E is then -2. Okay, so Devin, could you do the last part for us? We now have the coordinates of E and we have the coordinates of F. So we can now work out the gradient of EF. Okay. And we want to see if it's going to give us the same answer as the gradient for BG. So we said the gradient of BG is 7/10. If we can show that the gradient for EF is also 7/10, and then we know that the lines are parallel. So can you just check that for us?
Okay, so what you're gonna do is y2 minus
Mhm.
y1 over x2 minus x1.
Y2 minus Y1, X2 minus X1. Thank you. And what's this equal to?
Just give me a sec.
There's a double negative at the bottom. Just watch out for that.
Yeah, so it's gonna give you the same 7/10.
Perfect. Okay, thank you. Also 7/10. So we can say, therefore, gradient of EF is equal to gradient of BG. Therefore, EF is parallel to BG. And there you go. If the gradients are equal, the lines are parallel. Like I said, that is just one way of doing it. You could have also maybe have used the proportional theorem or the midpoint theorem. I was just looking at it now and I saw, okay, there's actually other ways of also proving the parallel lines. But you guys remember that for proportional theorem, you will have to prove that the sides have the same proportion. So the proportion for AF to FG is actually 1:1 because they are equal. Okay, so if you can prove that the proportion for AE to EB is also 1:1, then because they have the same proportion, they will be equal. Another way of also doing this is, like I said, the midpoint theorem. If you prove that E is the midpoint, sorry, let me do that again. If you prove that E is the midpoint, and we already know that F is the midpoint, then we'll know that EF will be parallel to BG, and EF will be half of the length of BG. So you could have used proportional or midpoint theorem, and either is valid, even though you are doing an analytical geometry question. That is still valid. Okay, last question here. ABCD is a parallelogram with D being in the first quadrant. Calculate the coordinates of D. Okay. The first quadrant, right? They say D is in the first quadrant. A, B, C, D. So A going down to the left, B going slightly up. I mean C, and then D would be somewhere there. Somewhere there. Okay. Now, here's my question. CV, maybe you can help me with this one. The coordinates for point A is 2 and 5, okay? Let's just keep that in mind. How many units do we go up from point B? And then how many units do we go to the right from point B to get to A? If you know this amount of units, you can move point C the same amount of units up and the same amount of units to the right. Okay, so remember these are completely vertical and horizontal lines. So I just want you to look at the Y values and tell me how many units does it go up. Then you look at the x values and you tell me how many units does it go to the right. And then we're going to do the same thing for point C. CV?
Yes, sir. Goes
Okay, how many units
C.
does point B go up?
The y value will go up by positive 7, so
It's from -5 all the way to +5. How many units? is that?
negative, I mean, yeah, positive 10, so
Yes, that's 10 units. And then from -6 to 2, how many units does it go to the right?
positive 8.
That's correct. From -6 to 2 is 8. Okay. Now we want to move point C also 10 units up and 8 units to the right. Remember, up and down movement is the y coordinate. Left and right movement will be the x coordinate. Okay, so let's add 10 to the y coordinate because it goes up, and let's also add 8 to the x coordinate because it goes 8 units to the right. What will the coordinates for point D be? The coordinates for point D. So 8 plus 8, that's the 16. And then -4 plus 10, that is 6. And that's the coordinates for point D. I just can't fit it in that small space there, but it's supposed to go on top. But by point D, 16 and 6. So this method is called the rise and run method. Rise and run method. And you saw I use this rise and run method when I want to calculate gradient before. Then I just look at the rise, that's the change in the y, over the run, which is the change in x. I used the rise and run method earlier when I did the midpoint. Okay, I did a similar trick like this, but then we did it the more sophisticated way I showed you afterwards, so to say. And then here you also see me use it to find the coordinates of a parallelogram. And so you can see how important this method is. Okay, so just make sure you know it as a backup tool if all else fails. But there are other methods that are maybe based around formulas. If you wanted to know how to do that, I'll just explain it quickly. I'm not going to do it because it would take long, but I'll just explain how you would get that. If point D is somewhere there in the first quadrant, we can draw diagonals for the parallelogram. You can draw the diagonal DB and the diagonal AC. And because diagonals of a parallelogram bisect each other, the point where they meet, that will be the midpoint for both lines. Now, if you can work out the midpoint for point A and point C, you can use that same midpoint for point B and point D. And then you can work out the coordinates of point D because you now have the midpoint and you have point B, so you can find point D. Okay. So this is using the geometry rule that the lines, the diagonals, bisect each other. Cool, let me just check what's the time. Now we don't have a lot of time left, but I really want you guys to do this question quickly. And when you are done, send me a picture of your solutions and then I'll check it as I'll mark it and then send you guys feedback on that. Yeah, so go ahead and start with, yes.
So you post this one also on the group?
Yeah, this is part of the same PDF, yes.
Okay, I didn't open it. Sorry, my bad. Apologies.
Okay, it's okay. Here are the formulas that you might need. We've covered most of this already. So the equation of a straight line, gradient formula. This is the gradient when they give you the angle of inclination. We mentioned the fact that when lines are parallel, that they're the same gradient. When you have perpendicular lines, that's the negative reciprocal. So the gradient multiply should give you the -1. I also briefly went over the midpoint theorem in that one question. Here's the midpoint and distance formula. And then the one that we didn't cover so far was the equation of a circle and the equation of a tangent. But I know I did this with you guys in class earlier in the week. So not study it, but practice this question now. And if you need help with anything, yeah, then let me know. So let's just go back to that question and you guys can get started. I'll give you like 10 minutes to attempt this one on your own.